Hello, and welcome to the lecture on 6.4. Today we're going to talk about the inverse trig functions. Now we've talked about these before, so going over this should be a little bit of review. And you'll often see that with trigonometry in general. We cover the same topics in different contexts many times in this class. In order to view sine, cosine, and tangent as one-to-one functions so that they can have an inverse, we restrict the domains of sine to negative pi over 2 to pi over 2, cosine to 0 to pi, and tangent to negative pi over 2 to pi over 2, exclusive in that case. And we define sine inverse, cosine inverse, and tangent inverse on the restricted domains. Those will look like this. Sine inverse of x is equal to y if and only if sine of y is equal to x. Notice the pattern matching. Cosine inverse of x is equal to y if and only if cosine of y is equal to x, and tangent inverse of x is equal to y if and only if tangent of y is equal to x. Notice the pattern that we have here. So x is the input of the sine inverse function. It's the output of the sine function. Now remember, sine, these functions here, sine, cosine, and tangent, they take an angle as input. So our y value, in this case, is an angle. It means that our y value over here is an angle. Again, the inverse trig functions output an angle. The inverse trig functions input a distance or a value. Sine, cosine, and tangent will output a value. You could think of it as a ratio, a value, or a distance depending on the context. Let's look at the domains and ranges of the inverse trig functions. Sine inverse has a domain of -1 to 1, a range of negative pi over 2 to pi over 2, inclusive. Cosine inverse is very similar, has a domain of -1 to 1, a range of 0 to pi, also inclusive. Tangent inverse, on the other hand, has a domain of all real numbers and a range of negative pi over 2 to pi over 2, but it's exclusive, meaning that we do not include the endpoints in this case, because tangent of negative pi over 2 and tangent of pi over 2 is undefined. Now I know that we've done this before, so we're going to go through a few examples. I expect that we probably know most of the stuff that I've already talked about, but let's go ahead and do a couple examples anyway. Example, evaluate sine inverse of root 3 divided by 2, cosine inverse of -1/2, tangent inverse of -1. Sine inverse of root 3 divided by 2 is going to equal some angle theta if and only if sine of theta is equal to root 3 divided by 2. So we need to figure out what angle theta makes sine yield a value of root 3 divided by 2. So if we look at our unit circle, we should be able to tell that sine is equal to root 3 over 2 at pi over 3 and at 2 pi over 3. But remember, sine has a range from negative pi over 2 to pi over 2, so 2 pi over 3 is outside that range, which means that we use pi over 3 as our angle. So theta is equal to pi over 3. Cosine inverse of -1/2. We're going to say that this is equal to some angle theta if and only if cosine of theta is equal to -1/2. So now we just need to figure out where cosine is equal to -1/2 on the unit circle. And that actually happens at 2 pi over 3 and at 4 pi over 3. But again, 4 pi over 3 is bigger than pi, so it's outside of this range. So we can ignore 4 pi over 3 as a solution. So our only solution, when we have it as cosine inverse of a value, is going to be equal to 2 pi over 3. Because 2 pi over 3 is within this range. Lastly, tan inverse of -1 is equal to theta if and only if tangent of theta is equal to -1. Now we have to remember here that tangent has a range from negative pi over 2 to pi over 2. So when we're looking for angles that make tangent equal to negative 1, it's going to be some angle divided by 4, some pi value divided by 4. Now, negative 1, tangent is negative in the second and fourth quadrant. So we're going to be looking in the fourth quadrant because negative pi over 2 covers that quadrant. So this will actually end up being negative pi over 4. You have to be careful with these negative signs. On the unit circle, the values are positive. All of the angles are positive. When we're looking at inverse trig functions, you have to be careful with sine and tangent because you don't necessarily have a positive angle. Sometimes you'll have a negative angle. If we were to look at these in degrees, this would be 60 degrees, this would be 120 degrees, and this would be negative 45 degrees. I want you to try one on the accompanying worksheet. Find sine inverse of negative 1/2. Cosine inverse of negative root 2 divided by 2. Be careful with these. Remember, you have to remember the restricted ranges for these two functions, so be careful with them. Now I want to do an example that we didn't do before when we were covering this exact same topic. This next example is a bit tricky. Find all angles between 0 and 2 pi for which sine of theta is equal to 1/3. So this is a bit tricky. First of all, I'm going to have to use a calculator because 1/3 is not on the unit circle as a value. Secondly, when we look at this, even though it's in the inverse trig function section, in the section about inverse trig functions, you have to look at this equation. We're looking at sine of theta is equal to 1/3. Let me draw you a picture of sine. I want you to note, first of all, that it's sine, not sine inverse. Sine inverse is nowhere in this problem. Now, it's meant to trick you a little bit because many students will think that there's only one solution to this problem. There's more than one. So this is our sine function, if you remember. If we're looking for when sine of theta is equal to 1/3, our y value is sine of theta. 1/3 would be right about here. We can see that on the interval from 0 to 2 pi, we can see that we actually hit the sine curve twice. So these are going to be our two solutions to this function. Now, where does that happen? It's a good question. In order to answer that question, I want to take you to the unit circle very quickly here. Notice that from 0 to pi, we have two solutions for every sine of some angle. So, sine of some angle, let's say that our angle is pi over 6. Notice that the y value, sine, is 1/2. But it's also 1/2 over here. So sine of pi over 6 and sine of 5 pi over 6 both yield the same exact value. What that says is that if we had something that looked like this, sine of theta is equal to 1/2, then we could say, well, pi over 6 is a solution, and 5 pi over 6 is a solution. But why can we do that? I mean, whenever we do an inverse sine function, we always only get one solution. That's because we restrict the range of sine inverse to be between negative pi over 2 and pi over 2. But also notice here that sine inverse is not a part of this equation. Sine is. Sine is not restricted in this equation. It does not have a restricted domain. So theta could be any value. That's why we also specify that it has to be between 0 and 2 pi. So if I can figure out this angle, how am I to figure out this angle? That's the trick. Because in order to solve a problem like the one that we have here, where we're looking for when sine of theta is equal to 1/3, we need to be able to find the first one and then use the first one to find the second one. So let's go back to our unit circle very quickly here. Notice that this angle right here, pi over 6. Now, for 5 pi over 6, the reference angle is pi over 6. This would be 5 pi over 6. Notice that this angle, when it's in the second quadrant, plus the first angle that we have, gives us 180 degrees or pi. So if we had pi over 6, we could find the second angle by subtracting it from pi. Because remember, pi is this distance here, all the way around. So if we take this pi distance and subtract off this little piece, we're left with this piece, which is the piece that we want. So if we try this with this problem here, and we say, well, we can find pi over 6 by just doing the inverse function. So we can say then that sine inverse of 1/2 is equal to theta. Well, that would give us pi over 6. Now, notice that we included sine inverse now, so this only gives us a single solution. But in order to find the other solution to this problem, we subtract this angle from 180 degrees or pi, depending on whether you're doing it in degrees or radians. In my case, I'm doing it in radians. So my other angle theta will equal I minus pi divided by 6, which is 5 pi over 6, for this case. Now, if we go back to our problem, we have when sine theta is equal to 1/3. So I need to figure out what sine inverse of 1/3 is. So what will this give me? Now here's where we need to use a calculator. So we do, I'm doing it in, let's do it in degrees. Inverse sine, or arc sine, of 1 divided by 3. This is in degrees. So 19.47 degrees. So my angle theta, at least one of my angles theta, is 19.47 degrees. Now, in order to find the other angle, I'm going to take this angle and subtract it from 180. So this would be theta 1. Theta 2 will equal 180 minus 19.47. That will give me 160.53. So these would be my two solutions, 19.47 and 160.53 degrees. Now you might ask yourself, why is this important? I promise you, when we get to the law of sines, this will become very important. This process, this particular process, is one part of another problem that we need to solve later on in the class. But for now, let's move on. Do another example. The line of sight from Cassian to Galen is 430 meters. If the horizontal distance between them is 404 meters, find the angle of depression at which Cassian is aiming at Galen through his rifle. So what this looks like is we have Cassian is aiming at Galen here. So we have Cassian here, Galen is here. And the horizontal would be this distance here. Basically from Cassian at the same elevation straight across to just above where Galen is. Now if we draw a line straight down, we can make a right triangle. Now this is the angle we're looking for. The horizontal distance, the distance of the horizontal, is 404 meters. The distance from Cassian to Galen is exactly 430 meters. We have this. Now we're looking for this angle theta here. So we need to ask ourselves, what trig function correlates this angle theta, the adjacent side, and the hypotenuse? That's going to be cosine. We have cosine of theta is equal to 404 divided by 430. Then we just find the inverse cosine to get our angle. 404 divided by 430. And if we plug this into our calculator, we get approximately 20.03 degrees. Try one on the accompanying worksheet. Yavin is no longer blocking the line of sight between its fourth moon and the Death Star. If the Death Star is 422,000 kilometers from Yavin center, and Yavin has a 96,000 kilometer radius, find the angle between the line of sight from the Death Star to Yavin and the line of sight between the Death Star and Yavin 4.
The Death Star has cleared the planet. The Death Star has cleared the planet.
Rebel base in range.
You may fire when ready.
I'm going to draw a picture for you because I realize that this is very wordy and very complicated. So the Death Star comes up to the Yavin system. So this is the planet Yavin. The Death Star is coming up on Yavin, and it's rotating around the planet. It's rotating this way around the planet because it wants to shoot Yavin 4. Here's Yavin 4. Now, as it's rotating around the planet, it has a line of sight of the planet, and then it has the line of sight from the Death Star to Yavin 4, the moon that the Death Star wants to destroy. So this is what we have. Here's the Death Star, Yavin 4, and it wants to shoot Yavin 4. We're looking for this angle. We know that this side is 422,000 kilometers, and this side of the triangle is 96,000 kilometers. So we're looking at this angle here, between the line of sight from the Death Star to the planet, and the line of sight from the Death Star to Yavin 4. So you need to figure out which trig function correlates the angle theta, the opposite side, and the hypotenuse. The next topic I want to talk about is evaluating expressions involving inverse functions. Right, in this section, we're going to do a specific example, and then we're going to generalize that example. Start with a very specific example. Let's find sine of cosine inverse of 4/5. So if we're looking for this value, we want to first remember that cosine inverse is going to give us an angle. It outputs an angle. The input is a value, the output is an angle. For sine, the input is an angle and the output is a value. Okay, so our answer is going to be a value. But what we want to do first is we want to take this inner function and we want to set it equal to some angle. So cosine inverse of 4/5 is equal to some angle theta. Now all we want to do is draw a triangle for this angle theta. So we're going to have some angle theta here. Remember, cosine inverse of 4/5 is equal to theta if and only if cosine of theta is equal to 4/5. So given this triangle here, we can label two sides of this triangle. Cosine of theta is 4/5, means the adjacent side divided by the hypotenuse is equal to 4/5. So I'm going to label my adjacent side 4 and my hypotenuse 5. Now, in order to find this third side, all we do is the Pythagorean theorem. We'll call this a. We have a squared plus 4 squared is equal to 5 squared. A squared plus 16 is equal to 25. Subtract over and get a squared is 9. So if we took the square root, we would have plus or minus 3, but it suffices to say that it's actually just 3. So we have our final side of the triangle is 3. Now notice here, cosine inverse of 4/5 is equal to theta. cosine inverse of 4/5, this entire function with the red underline, is equal to theta. The exact same thing. So now all we're looking for is sine of theta, given this triangle that we constructed specifically with theta in mind. Now, I never actually find the value of theta because I don't need to. It doesn't matter. If I'm just looking for sine of theta, I do opposite over hypotenuse, I get 3/5. Very straightforward. So what that means then is that sine of cosine inverse of 4/5 is equal to 3/5. Now we can generalize this to have an unknown value. So suppose that we have this one instead. Tangent of cosine inverse of x. And we're trying to find this. Now we do the same exact thing. We underline cosine inverse. We know cosine inverse is going to output an angle. So we have cosine inverse of x is equal to some angle theta. We draw a triangle. And we label an angle theta. Now cosine inverse of x is equal to theta if and only if cosine of theta is equal to x. Now we can also say that this is x over 1. Then we know that the adjacent side is x and the hypotenuse is 1. Because cosine of theta is adjacent over hypotenuse, so x divided by 1. We do the Pythagorean theorem to get this third side, and we have the square root of 1 minus x squared. Then we're looking for tangent of theta, because cosine inverse of x, this underlined part, is equal to theta. Now we're just looking for tangent of theta. We need to figure out what this is. Now remember, tangent is opposite over adjacent, so this is going to equal square root 1 minus x squared divided by x. And that will be it. I want you to try one on the accompanying worksheet. Evaluate sine of tangent inverse of x divided by 2. Just follow the same exact process. Be fine. All right, that's going to be it for today. I will see you all in the next lecture.